Awesome. All right. Well, welcome everyone to uh, hackathon session here on front-end development on Secret Network. And I'm really excited to present this stuff to you guys today. And hopefully you get a good overview of how Secret Network is working from a front-end development perspective, as well as how an integration with some of the Shade Protocol smart contracts would work. Um, First of all, I guess a little bit of an introduction to myself. So my name's Austin, one of the Shade developers. My main focus has been on building the Shade app, the front end side of it. I've also been involved a little bit on some of the back end infrastructure, but mainly my expertise is front end. I'm also the technical lead, I guess, on the grants program. So I'm involved with a lot of different grant teams and helping them execute for building on top of Shade. So that's a little bit about myself. I've been doing this for about three years now, working on Shade Protocol stuff, and it's been a really fun journey. The goal of this session is to become familiar with how to interact with Secret Network. We'll talk a little bit about encryption and privacy. We're going to learn about using SecretJS, which is a JavaScript tooling for Secret Network. We're going to learn a little bit about ShadeJS, which is a wrapper around SecretJS, specific for making Shade protocol integration simpler. We'll learn a little bit about how ShadeSwap works, and hopefully by the end of this session, we'll actually make a swap on ShadeSwap. That's sort of the end goal here as a demo. So prerequisites for this, for getting the most out of this session, I guess. My hope is that you have some familiarity with HTML and JavaScript. I'm not going to dive too much into that or explain that there, but and then I'm going to be working specifically with a Vue JavaScript framework for my demo. But if you've used React or something similar, should be pretty straightforward. So that's a couple things you might need to know. And my agenda here, so we're first going to start talking about queries and how to do basic Secret Network queries. And we'll get into SecretJS client management for making a query. We'll interact with a smart contract and get data out of it. And then we'll talk about encryption and some private queries using viewing keys. And lastly, we'll talk about ShadeJS, which sort of bundles some of those things together and makes them really simple. Then we'll get into the execution side, where we'll have a signing client management, which is like a little bit more complicated version of a query client. We'll do wallet setup and integration. We're going to specifically focus on Kepler today, but other wallets are similar. And then we'll do contract message generations and then broadcast it, and hopefully wrap all that up with an actual shade swap. Excuse me. So the basic Secret Network node queries are we're going to be using Secret Express today. Secret Express is a public API for Secret Network. I linked the docs here. Secret.express talks a little bit about it. And this is the endpoint we're going to be using. And before I get into, so what I'm planning to do here is, as I'm going through each of these aspects of this presentation, I'm not just going to talk about it, but I'm actually going to be live demoing code as we go. And I want to give you guys an intro from the very, very beginning, even from like basic setup of the project. So that's what I'm going to start with, and hopefully this won't take too long. But I just want you to get an idea that this is the setup from the very beginning. So let's see here. All right. So first of all. So we're gonna do, just make sure I got the right command here. So bear with me for one moment. We're gonna set up a basic view project. All right, so here, yeah, create view. Yes. So we create, no, script, no, 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 no. We use yarn to install the project. Open it up here as well. All right, so here we got a basic project. Basic template for a view app here that is now running. I'm gonna clean it up real quick so that we can just strip down to the stuff we really care about. Delete all this out. We'll just work out with the main app.view. Take all this stuff out. See where that leaves us. Second, bear with me. All right. Now we have set up a basic project that is working. Let me just quickly build out a couple little things. So I'll get a template going that we can work with. So this part not super important. So it's a project that we can work with. Make a button. Let's see. And we're gonna spin up a few of these soon, but click this and there you go. It says clicked. Got that. I'm gonna apply some really quick styling on that. I just want to get a basic setup going. All right, cool. So we got a button and some variables that we can work with. So let me hop back to my presentation quick. This. All right. So let's talk about basic secret network query. And what we're going to do first of all is just do a query to get the total supply of secret on secret network. I'm going to open up the Swagger here to show you guys that this tool is available. So this is the documentation on the API that we're going to work with here. So you get a lot of different data out of this. So we're going to focus on one in particular just to get the total supply, the current total supply of secret on secret network. So I'm going to hop back into the code and we're going to set that up. So for starters, I'm going to make a an example here of this a node query, and so we're going to make an async function called get secret. And so we're just going to do a basic fetch, and how this is going to work here. Equal. So I'm going to fetch. I'm going to use that public endpoint that we talked about earlier. So secret express. All right, so we're going to do fetch at plus the these guys here. So for example, if we're going to work with total supply, we got this one here, Cosmos Bank V1 beta supply. Actually, if we take our endpoint and query it here, you can see that this is the amount of secret that's being returned. So we'll take this query, we'll add it into our project. And then the JSON resource. Return. Uh, that should get us the secret supply in our project. So let's try importing it. See how this goes. I'm gonna try A little bit of a weird thing with VS Code here. I'm going to try to restart my environment and see if the imports will fix itself. All right, that looks better. So let's run this. What we get? All right, got our project here. Click and let's check this. Let's look over here. I have a typo. Okay. Again. All right, there we go. So now we clicked that button, we queried the chain, and we got the total supply of secret. That's obviously as a udenom, and secret has 6 decimals. So if we wanted to, we could do a little bit of math on it. Do a string. There is the supply of secret. So there is an example of how you would interact with the node to get some data out of it. And yeah, again, we're using Secret Express, a public API, or you're free to use this in your project. The next example I want to get into is SecretJS and interacting with the smart contract there. So that's what we're going to do. All right, so I think the thing we're going to try is querying a smart contract to get information about a token, specifically a SNP20 token. You should be familiar with SNP20 tokens, but if you're not, it is the private token standard on Secret Network. And these type of tokens all have encrypted balances, so they require viewing keys to be able to see, but there is certain public data that you can query also for these SNP20s, and that's what we're going to start with. So let's first, before we get started on querying a specific SNP20, we need to learn a little bit about SecretJS and secret clients. So that's where we're going to start. Make it you here. And we're going to need to add, first of all, SecretJS into our project. I'm going to do that first. So how do we do that? You can read the doc. So we'll add SecretJS into the docs real quick. So here's the SecretJS docs. Information about installation, integration with various wallets, how to use the API, as well as a lot of different message classes and things that you can work with to do a lot of different things. I'm just going to talk about a couple basic ones today, but there's a lot of great information here if you want to dive deeper. Now, let me talk about creating a query client. So a secret client is basically the tool you're going to use to interact with the chain. You can do queries with it, and you can also do things like broadcasting messages and executing transactions. Start with just the query aspect of it. So I'm going to make a function called query one. So I'm just going to set up a client in order to make a query. And what this is going to do is your network. So let's first import that from the JS and create a client. A client has a number of parameters to set it up, these create client options. And the very basic ones you need is a URL, which is like an LCD endpoint, and the chain ID. Those are the only two things that are required. Everything else, part of the client, has to do with user-specific data. But to make public queries, all you need is an endpoint and that chain ID. So let's start with that. We're going to use the same exact endpoint as before. The endpoint, Secret Express. And we're going to give it a chain ID. And chain ID, secret, is secret 4. And really that should be everything you need there to make a query client. Now let's utilize the secret network query client and actually get some data. Okay, let's make it info 20 info parameter of contract address. Client, and then we'll make a query with it. So client query. We're going to use compute. You read more in the SecretJS docs about this and various options. And we're going to query contract. So this has a few different parameters. One is the contract address. And you can also optionally pass in a code hash, which is always recommended because it's fastest. If you don't pass in code hash, then you'll have to, like under the hood, it will do this extra query to first get the code hash. But not required. I'm just going to skip it for now. Yeah, just to keep things really simple. So then we're going to do a query. And the messages for SNP20s, you can look them up in the SNP20 docs, but I am just going to do it here since I already know what it is, but there's a token info query. That is this message right here, really simple, basic empty object. All right. And try it out. So this should query the token info for SNP20. Something here. Well, get shade info. Right. Simply shade. Now get token info. Get SNP20 info, sorry. SNP20 info has a contract address as an input. Let's input shade. The shade token. The shade token contract address is going to be this right here. And that should give us information about the Shade token. So we'll see how this works. Our project. Hope I restart the server. All right, so got the secret info, and let's see if we get token info. We're getting it right here. Oh, that's the secret info. Check if I got any warnings. All right, so we're making the query. We're just not displaying it for some reason. So got a little bit of a bug. So we didn't return it. All right, there we go. So we got token info, the name, the symbol, the number of decimals, and the total supply in udenom. So that is value query plus step 20. So that's a public contract query. Now I want to talk a little bit about private queries. There's also secret network has encryption, obviously, and certain data is private and requires either we'll just talk mainly about viewing keys today, but there's two different ways to decrypt data for the users, and one is with a viewing key, which is a string that the user executes on the contract in order to see their data. And then once they execute on the contract and set their viewing key, then they can use that viewing key string and query data like balances, for example. So I'm going to set up a second function here, specifically for getting the balance, and I'll show you kind of how that works. It's, and it's going to be all the same, except the message structure is just going to be a little bit different. All right, so the contract address remains the same. Hold on just a second, guys. I'm getting too many messages. All right, sorry about that. Let's do the balance query. So instead of token info, uh, you're going to do a message called balance. It's going to have two properties, address and key. So the address is going to be my own personal address. Typically, you'd want to like pull this out of the wallet and have it synced up with your application and pass that in as a parameter. For now, I'm just going to hard code it just to keep the demo really quick and simple. But here is my address. And I've already set my viewing key inside of Kepler. So we're going to use that today. That is going to be this string here. Right, so we have a message called balance, two parameters, user account and their key, and that should return what the balance is for the user. Hit the Let's give this a shot and see how it goes. All right. Yeah. Secret address. Oh, I think I have a little bit of a typo. All right, here we go. Yeah, we have the balance worked. And now you can see what the user balance is. Now, let's say, for example, I was querying with, or I didn't have the viewing key, or I was trying to see this person's data and I didn't have their viewing key. Let's say I passed in something different. So instead of the viewing key, maybe I passed in another string. Like that. And I try again to make that query. What I'm going to get is something different. Be first. Viewing key error, wrong viewing key for this address, or viewing key not set. So that's an example of the response you're going to get when you don't actually have the user's viewing key. Let's set that back to ID. So that concludes a basic example of how to do a public query of a smart contract as well as a private query of a smart contract using the secret client. Next, I want to talk a little bit about ShadeJS. So ShadeJS is a wrapper library for SecretJS, and it's meant to be developer tooling to allow you to really easily get started with Secret Network and Shade Protocol. I linked the docs there in my presentation. It's shadejs.dev. Encourage you to check it out. Um, but it's got a lot of helpful functions for right now. It's mainly focused on shade swap, but it also has some basic SNP20 things that we just talked about, like getting the token info or getting the user's balance. So I want to show an example of getting the SNP20 token info. Again, we'll do it one more time, but this time we're going to use ShadeJS, and you'll see just how much simpler it is. And what's happening under the hood is it's initializing the client and passing in all the relevant parameters and returning the results. So it's doing what I just did here, just in a little bit simpler way. So the installation for this. Let's add ShadeJS in our project. All right, so downloaded ShadeJS, and let's import it. It's, or rather, query. Oh, protocol ShadeJS. All right, so we have this function here, which is going to do everything that we just did. So I'm going to set up a second one. Just say shade info to token info using the this time we're going to use this. And the only parameter we need is again the SNP20 contract address. You don't even need an endpoint, because under the hood it also is referencing Secret Express. Shade info. Start the server. So the original get token info. Should be coming, might be slow. There's the ShadeJS one that worked right away. Maybe I messed something up on my other one. Let me just check that real quick. You can see two different methods getting the same data. That ShadeJS one took, all of a minute to set up and reference. So that is why we made ShadeJS, was just to allow people to super easily start to integrate with these contracts and get the data that they care about. So I encourage you to check that out more. It's always a work in progress. We're continuing to build it out for all different parts of Shade. Right now, we're just focused mainly on the Shade swap right now, but we will be getting into other parts of the app in the not too distant future. So, yeah. Next, we're going to get into execution. So in order to execute a contract, you have to be able to sign transactions. And we need to extend what we've learned so far about the secret client to pass in signing information from a wallet. We're going to focus on Kepler today as the wallet for this demo, but other wallets would work in a similar manner. There are docs here that Kepler has specifically focused on Secret Network because there is extra encryption utilities that they work with. So they have an API for that, which makes it really nice and easy to work with there. So yeah, let's jump in. So what I would like to do as a starter for this would be to set up Kepler, because there's going to be a number of Kepler functions we're going to need to build out the secret signing client. So let's make a new file here, call it Kepler. And there's going to be a few different things we're going to need. First of all, as a one-time setup step in the app, you have to enable it, which allows you to actually have the wallet connect into the app. You don't need to run this every time the app loads or anything like that. It's literally a one-time setup step. So let's make a function called enable Kepler. We're gonna probably want to start here. We're gonna reuse this a few times. So, um, so in order to get some more information about what's actually available in window.kepler, there's some really nice TypeScript tooling that Kepler provides. I want to start us off by downloading that. That will help make things a little bit more clear here. So it's something called Kepler wallet /types. And the second thing I'm going to do is make a extend the window object to allow us to actually understand what that is. Mm, copy this over. So that should be what we need there. Or sorry. So with that little TypeScript extension of a window, you're able to see what the types are that are available, or what the object is with this window.kepler. All right, so we have a function called getKepler. So I'm gonna grab that, use it here for enabling. Run Kepler.enable. And then for this, we're going to need chain ID. So that's going to allow us to enable Kepler. Let's actually try it out. Over here. Button here. And then we'll run enable Kepler. Let's go. All right, so we got this button here. I already have Kepler installed in my browser. If you didn't, you'd have to do that first. But assuming you have the plugin installed, click Enable Kepler and you get this pop-up and it says, hey, it's requesting connection. And once you approve it, then you are now connected to the app. And you won't have to do that again every time. Like I said, that's a one-time setup to allow you to actually communicate with the wallet. So we have Kepler enabled. What else do we need to do? Well, we're going to have to get information about the signer, and we're also going to need to get some encryption utilities out of the wallet. And that is some secret network stuff to allow the user to make transactions and also have the encryption information stored so that when you get your transaction data back, you can run a decrypt on it and see what that data actually is. All right, so I'm going to make one called Signer. This one, we're going to use the Git offline signer only amino. Use amino signing for this. And let's see, we have the only thing we need here is the chain ID, so pass that in. And this is going to return our premise. That's going to return offline amino signer. I'm going to add one thing which will help with the TypeScript stuff since I'm working with TypeScript here. Import signer from SecretJS. I'm going to declare this as a signer. Yeah, that just helps with the TypeScript a little bit so that SecretJS knows exactly what this Kepler function is. Another function we're going to need, so we're going to need the signer, and I also mentioned encryption utilities. Here called get enigma utils. These are going to be the encryption utilities for users wallet. All right, so that gives us the encryption utilities. The last thing we're going to need is the user's wallet address. Now, technically speaking, the user's wallet address is going to be available inside of the signer here, but I'm just going to split it out just to keep things simple. Because there's different use cases when you only want to get the address, you only want to get the signer. So I'm just going to split it out. The wallet address. Do this again. However, this time we're going to return something different. Account data, so see what it's signing. Always the zero index of the account. Address. Some pesky TypeScript issues. We'll just add this, force it to think that it's definitely going to be there. So we got the offline signer, we get the account, and we get the address from the account. So those are the three core functions you're going to need to work with Kepler. There are a bunch more things as a part of their API that are useful for doing wallet management inside an app. Things like monitoring events, or if the user changes their wallet while they're on the app. And there's other different types of signing you can do. And there's other data you can get at. But these core three right here, getting the signer, getting the address, getting the encryption utilities, are the ones that mainly we're going to care about for this demo. For these. And now let's hop back to our client, and we are going to set up a second type of client. So before we were working with a query client, but now we're going to make a signing client. Create signing. Right, so in this case, what we're going to do is return the secret network client. And however, we're going to use some additional parameters. So we have the URL and the chain ID. That's going to be the same as before, but this time we need to add signer. And we're going to have to add a wallet address. This thing first. Signer, wallet address. So we have those three functions there. Let's start by setting some variables here. Returns a promise, so wait it. All right, so we get the signer, get the wallet address and wait for it. And then we get the encryption utilities and pass that into this more powerful secret network client that's going to allow us to actually make transactions. Um, so yeah, let's export this. We can just take a look at it on the front end for starters and see if we're getting any errors or anything like that. So let's import our it signing int. So signing client value equals. So hopefully that returns a secret network client and we can display it.
Dad, can you make this into a takeaway airplane?
Hold on one second. I'm on a call right now, okay?
Oh.
I'll help you with that later, all right? Okay. Well, I'm presenting right now, okay? So can you, I'm gonna have to help you out with that later, okay? Sorry about that. All right, where was I? We're gonna get the signing client. Enable capillary, don't do that again, but if you didn't, this wouldn't work. But get signing client. We got some kind of error. check this out quick. Some kind of minor thing. It's probably returning some type of complex object. So let's do this instead. Try to just magnify the JSON and we'll see if that works. There we go. Cool. So there's all the data for the secret signing client. And yeah, should now be able to execute transactions. So we talked about how to set up Kepler. We talked about how to set up the signing client using all that Kepler different APIs. And now I want to jump into how we're going to use this signing client to actually execute a transaction. And we're going to try to set this up for we're doing a swap. Okay. So let's add a file called start. And there's going to be a few different pieces to building out the message to sign execute. The first thing is we're going to need a message class coming out of SecretJS. And this basically tells SecretJS what the transaction type is, and then it uses the data and properly signs it and sends it up. So import message execute contract, because that's what we are going to do right here. And like I showed you guys earlier, I can pull this back up quick. In the SecretJS docs, there's a lot of different message types here that you can work with. We're going to be focused specifically on message execute contract here. So yeah, just wanted to point that out. And so let's see here. What we're going to do for starters is going to be setting up our snip20 send. So how a swap contract works. I don't want to get too technical, but swap, how it works is you're taking a snip20 token, you're sending it into the swap router contract, and then the router performs the swap and returns the tokens back to the user. So the type of message we're going to be sending is a snip20 send message. And we're going to build out the structure for that first. Then we're going to pass that message into the message execute contract class that I've imported here. All right. Rather than just typing this all out, I'm going to reference some of my own code that I've already written in order to save a little bit of time. And I don't want you guys to think that I have this memorized or anything. So let me hop over to this here. So we're going to copy this. All right, so here is a message snip20 send. And the structure of the message is an object property called send. And inside the send, we have a recipient, a recipient code hash. We have an amount that's in udenom, and then a handle message. And the handle message is going to take the extra data that the smart contract is going to need when it receives the tokens to actually do the action. So in this case, we're going to be sending tokens to the router contract, and the router needs to know which swap pools we're going to be using to actually perform that swap. So here's the structure of the message. That handle message needs to be encoded into a base 64 string. We have a utility function for that available in ShadeJS. For that here. That's everything we need for the snip20 send message. Now we're actually going to need to make the swap transaction. So again, I'm going to copy this in here. Oh, full message swap here is going to be, we're going to have a formatted path. So this path will determine the swap pool is going to go through. And then we're going to form it into this swap params message, which takes in the paths that it's going to travel through, as well as the expected return.
قدن.
And so that params message will get passed in as the handle message of the snip20 send. And then in addition to that, we're going to have padding as a property passed into the snip20 send. So I didn't mention that before, but padding is just some entropy string that's you randomly generate, pass it into the message. And that just changes how the message looks, how it's being signed, so that someone that's watching transactions as they're happening couldn't infer what exactly a user is doing because that padding is changing the structure of the message just a little bit. So that's all that padding is. And we have I have a little padding generator function that I will pull in here. Let's do this. By the way, I will share all this code after this call is complete, so you can go back and look through it yourself. Here's a random padding function, which is just generating a string of random length, and we'll use that and pass it in. Lastly, this message execute contract. Gotta tweak that just a hair for what we need here. So message execute contract imported before. It's gonna have oh, I think I imported the wrong thing. Looks much better. So got message execute contract. Now I should actually get some parameters out of it. So this is going to be what we care about here. All right, so the sender is going to be the source address, contract address, contract address. For making a snip20 send or executing on that snip20 contract. The message is going to be what we set up before. This message snip20 send. The sent funds That's not going to apply in this case. And the code hash is also going to be this snip20 code hash. Source address. Yep. Yep. All right. And then there's some types here. We'll pull those in. Copy paste. Basically, it's just an array of pairs. Pairs. We're going to have an address and a code hash. So that's all those types are used. That gives us the swap message. Now we're gonna need to get some data and then we'll execute this swap message. So let's try to set that up. Let me check. Some people. Where were we? All right. So in order to execute the swap, we're going to need some information about the contracts that we want to work with. And I want to show you guys some ShadeJS queries in order to get at that data. So the data we're going to need is obviously about the pairs and the amount of liquidity that the pairs are going to have. Well, actually, in this case, we don't really care too much about liquidity, but we are going to want to look at the pair data, and then we might have to do a little bit of routing to be able to formulate this message. So let's hop in and try to do that. So I'm going to start by going back to our swap file here. And I want to make a message that's going to get some data from our swap contracts. So you want to pull up ShadeJS here quickly. Show you guys what I'm going to be working with. So for our swap, we have information about the factory. The factory is what generates swap pairs. So you can use the factory to get a list of swap pairs. There's also a pair config query, which allows you to get the configuration data for multiple pairs. And we also have a pairs info query. And the pairs info returns data about the pairs, like tokens that are involved, the type of pair it is, the amount of each token in the pool, the fees, stable parameters if it is a stable pool, as well as there's a couple other things in there that are useful. But what we're going to try to do is get the data from our pairs, and we're going to try to use those to do some routing sort of calculations. And inside of ShadeJS, we have an example router for how to do routing. So you can get the possible paths based on the input of 2 tokens, and you can calculate the route input and output. And you can do, you can do route optimizations and determine what the optimal path is. We're probably not going to do all that today. I'm going to try to keep it as simple as I can. start with just trying to get some swap data. So let's start with getting our factory pairs. This query factory registered pairs should be pretty useful. So as a show you what this is. Query factory. Query factory pairs. We're gonna work with here. Yep. Factory pairs. Now the only parameter we need for this is going to be contract address, starting index, limit. Inside of ShadeJS, we have a list of contracts here in the contract registry. So we're going to be working with this Shade Swap factory contract. Paste that in. Limit. We're going to return. I think it should get all of them. I think we have more than 50. Starting index. I think maybe should be all we need. Open up the project here. All right, get factory registered pairs. We'll see how this goes. All right. Now you can see this long list of pairs. And this is going to be all the pairs that Shade Swap has. Try to make that a little bit easier to read. So first piece of useful data we're going to want is getting a list of all possible pairs. Then second, we're going to need to get information about all those pairs. So let's put another one here. Pair config query. Let me check the docs. Make sure I got the right one. Swap pairs info. Oh, it's going to be batch query pairs info. It's okay. Pairs. The information we're going to need here is going to be the query router. Let me talk briefly about query router. So query router is a smart contract that allows us to batch query multiple contracts at one time. This greatly improves the performance of the queries and also just reduces load on the node. So if I want to get data on 50 pairs, I don't have to do 50 HTTP requests to the node. I just do this single batch query. So we use a query router for that. Um, and then we pass in an array of pairs contracts, and we're going to get those pairs contracts from the previous query that we just did. So let me actually, yeah, that should be fine. So we'll pass in. Router, I'm going to hop back to this registry here, shade swap router. And we don't need the code hash. We can just skip that. This helps make it a little bit faster. And we'll pass in contracts. All right, so now that we have that, and let's import that into here. And what we're going to do is pass in an array of contracts. And what I'm going to do is say factory factory registered pairs. And we'll do something interesting with this. So that's okay. Uh, this. errors everywhere. That gets us there. We should just be able to do and do some quick formatting on this. Needs address and code hash. So it's out here. It's pairs. Okay. We'll give this a try here. Get pairs, pair info. Some kind of error. Start by getting the factory registered pairs. That should make a query. And then we'll get the data associated with it. Buffers not defined. Oh man, I need a polyfill buffer. One moment. Do we need to import buffer? Let me first of all try just importing it. something here. See if that does anything. Buffers not defined. Okay. Well, we might be striking out on this one for now, because that's going to take a little longer for me to dig into on why that's not working. But I can talk through at least the strategy here, and then hopefully wrap up the demo. Even if we can't fully successfully get all data and do all routing, I should still be able to execute a transaction for the purpose of the demo. So the idea here is we're trying to get all the data for all pairs. Using that data, you can put it into a router and determine the optimal path. I think what I will do in lieu of that is to sort of manually do a swap message based on more hard-coded pair data that I'm aware of. So I think that's going to be probably a good way to wrap this up. So let me try to set that up for you guys. We've already talked about how to get the secret network signing client, and now we're going to use that to actually broadcast the transaction. So let's try to set that up here. What we're going to want to do is set up like a final sort of swap transaction here. And I'm going to jump back to what I was talking about before. We define the message. We set up this message execute contract class. And the last piece to sort of put all this together is to use our sign client. So what I'm going to do here, I'm going to copy paste this in. I want to talk through it. So we have a send swap transaction function. What this does, it takes in source address, the step 20 that we're going to be sending, the router contract. So what's going to accept the tokens and make this transaction, send amount, minimum expected return amount, and the path as well as the gas cost. How we're going to, first of all, signing client. So we can put that here. Client, we will run client.tx.broadcast. We will pass in an array of messages. In this case, we're just doing a single message, which is this create message swap. And then there will be a gas cost associated with it that gets passed in as a parameter, as well as the gas price, which is like a multiplier applied to the base gas cost. And 0.25 is currently the secret network standard for that. And so what we will now do is try to, well, more manually, I guess, populate this paths parameter into this function, and then it should work. So yeah, we'll see how it goes. Let me export this, send swap transaction, and we'll go over here. And I'll make that bold. All right, so let's get all these parameters. Okay, so our source address, we're going to actually know from the wallet information. However, decide if I want to pull that in now, I certainly can. So get our wallet address. Somewhat redundant because inside of the client, there's also a wallet address available, but that's okay for now. All right, so we got the wallet address. And we're going to need the SNP20 contract address. Let's say we're going to send shade, so we're making a shade for something else swap. Grab this address here. Code hash not required, so we'll just skip it. Okay. Router contract address, which we already have in here somewhere. Yes, here it is. Or no, sorry. We're talking about a different kind of router here. Let me hop back to ShadeJS docs. And we're talking about the shade swap router. So I'm going to grab this router address. And the router code hash shouldn't be required. And then our send amount. Let's say we're going to send the one shade, and this would be in Udemy, so that have 8 decimals. And let's say there was 10% slippage, which is really high, but let's was then we would do all right. So I want to get at least 0.9 shade, or sorry, let me restate that just to be clear. Send amount is the amount of shade that we're sending into the contract. The minimum expected return is going to be the amount we expect to get out, and that's going to be dependent on the type of token that we're trading for. So it's not 10% of the send amount. Disregard what I just said. Uh, but let's just say for now we're expecting to get one token out, just for the purpose of the demo. And then lastly, we need to formulate this paths object and the gas cost. So just to refresh, paths is going to be an array of this here. So let's say we were just making a single pool swap where all we're is going through a single pool. This isn't going to be a multi-hop routing. And I can get one as a real example. Let's see, bear with me. Can grab one. This is a real known one. I was hoping earlier to be able to query all of these and actually sort of identify which one we care about. But since that was failing for me, I'm going to have to do a little bit more manual. All right, so if I were to grab, let's say, the Shade Silk pool, I have the contract address here. And go to type, that's going to be set something really high to do 2 million guys. Now, if I go down here and I make one more button, watch, you will see how this goes. This. Thing. I'm also still getting the buffer area. But it might have a way to get around that for now. Just going to try it more manually. Instead of importing it, I'm going to do it straight away. So me, to be able to execute the transaction here, but I should be able to complete the demo and at least get a couple of pop-up. So let's scrap that. So instead of encoding the JSON to base64, what I'm going to do is just put in like a mock string. So and we'll see how it works. So we're executing a swap. We're executing this snip20 send. So this is a shade contract address. We're making a send. The recipient is the router. You can see the amount here that's being sent in shade. The message is currently a mock base64 encoded string. Due to the issues I'm having with buffer, we need to troubleshoot that a little bit more. But it would basically be an encoded version of the message, and that the handle message that is, and that handle message is this data right here, or this swap params message. That swap params message makes up the pools that it's involved, and you also pass in that minimum expected return amount. So that would be the full, and also then the padding. So that's the full data for the transaction. You can see the 2 million gas that we set, which is also pretty high. And that message that's being signed. So if I were to sign this and send it off after fixing the base64 encoding, that would perform a swap. It would send one shade into that pool, and it would get a certain amount of silk out as long as it was above, and it would only error if it was above or below that minimum expected return. And we set that to be a really, really low number here in the form of 1 micro silk. So yeah, that is how you would execute a swap. Unfortunately, I had some issues with my demo today, but I was kind of hoping to show you guys, you can get data from all of our pairs using these ShadeJS queries. And we also have inside of ShadeJS this, where is it? I have too many tabs open. There. So inside here we have information about how to make routes and how to actually execute those. So definitely take a look and yeah, integrate with shade swapping. And we'd be happy to help answer any questions, or if you're coming across any problems when you're working with ShadeJS, definitely put in an issue on GitHub and we'll get it fixed.
Dude, this might be
So
one of the best zero to hero tutorials that I've ever seen. This was so thorough. Yeah, even if even not being able to do the swap, like being able to show everything you'd need to do, from like understanding all the components that go into building front end, and being able to interact with smart contracts from user interfaces. It's so cool. I know people are gonna be going back and watching this. This is like the perfect video supplement to the ShadeJS library. So really excited to have people check this out. I know we'll make sure to break it up so people can go directly to the portions that they need help on. Like if everyone understand, like if some people understand the components, they want to go straight to like how do I build swaps or how do I execute things. Yeah, this is going to be super helpful. I really appreciate the thoroughness here, Austin.
Yeah, I'm a little bit bummed it wasn't like a little bit smoother, especially near the end, but all the information is there, and it's uh it's it's software. There's always going to be little bugs and issues that you're dealing with, but I hope it gave a pretty comprehensive sort of zero to hero type of thing.